There goes electricity. Again. How can solar energy be used as an alternative green energy in daily life? Good day, everyone. I'm Phoebe Mariposa from Jubilee Christian Academy, Philippines. And together, let's explore how solar energy can be utilized as an alternative green energy. Our first experiment is a solar-powered water bottle. First, add water to a plastic bottle and fill it around 75%, leaving some space at the top. You may also add a few drops of bleach to prevent the growth of algae. For this experiment, a cardboard box will be used. Cut a hole at the top of the box that is big enough to be able to insert half of the water bottle through it. I added another layer of cardboard to secure the water bottle in place. Now, we'll be putting everything directly under the sun for the real test. The inside of the cardboard box is fully illuminated. This is because when the sunlight hits the water bottle, it gets refracted due to the change in medium, from air to water. When light enters a denser medium, it slows down and changes direction. This bending direction change of light is called refraction. But what would happen at night? Now this is where solar panels come in handy. The same setup from the first version is still used, however, we will be doing additional steps in using solar panels, batteries, and LED lights. During the day, we'll leave the solar panel directly under the sun to get enough sunlight. And at night, it will already be fully charged by the solar energy. But how does this work? Solar panels are made up of multiple individual photovoltaic cells composed of semiconducting materials. This has two layers split into negative and positive. The N-type layer with excess electrons contains silicon and phosphorus, while the P-type layer with holes or lack of electrons contains silicon and boron. At the p-n junction, the electrons from the N-type layer will move across, and the same goes for the holes from the P-type layer. And this leaves a slightly positive and negative charge on its respective opposite regions. This creates an electric field forming the depletion region wherein no electrons or holes can exist. When sunlight hits these photons penetrate the N-type layer and reach through the p-n junction. And with enough energy, these photons excite and transfer their energy to the electrons of the atoms, which makes them free-moving and also leave behind positively charged holes. The electric field will then forcefully pull these free-moving electrons towards the N-type layer. The leftover hole will then be filled by other electrons, causing a domino effect, wherein the hole ultimately drifts towards the P-type layer. The free-moving electrons will then flow through the circuit until they reach the other side of the solar cell to then combine with the other holes. And this overall creates the current. Solar panels convert solar energy into electrical energy, and this flows through the circuit and powers the LED light. By storing the solar energy into the batteries, this can be used even at night. This proves that solar energy is a green alternative energy that we can use throughout our daily lives.